Take it everybody can see the screen all right.
Yep.
All right.
All right. Have a good one, guys.
You too.
See you, Ryan. So, as usual, if you could please mute yourself. Friday, we had a let's see here. We had a video that was, I know it was long. It was 2 hours. It was kind of intended. But when the video was over, there was a lot of noise where a lot of participants, or maybe just a few, it probably doesn't take many, who had walked away from your computers without muting. And there was music, there was God knows what. I mean, there's just a lot of background noise that we couldn't answer questions. I mean, it was like a sensory overload. So please be mindful of that. If you are one of those people that turn on the computer and then walk away from it, that's between you and your employer. But please, have some common courtesy and mute. Because the host, we can mute everybody. Like I went in just a second ago and muted everybody, but if somebody comes in a little late, then they're not muted. So just be mindful of that. Let's see, also, what is this, your guys' 4th week or something like that doing this? This is starting my 3rd week back. So I'm aware it's getting old. Hopefully, the governor last week had said something, by May 1st, they're going to start kicking in some things. During the PAC meeting on Thursday, it was mentioned, it's not set in stone, but the PAC's starting to talk about it, about getting people back out into the field. No dates were given, anything like that. And I know a lot of it's based on governor, the state policies and such. So there seems to be, I guess, a light starting to appear at the end of the tunnel. And I don't think it's a train coming at us. I think it's an actual light. So as the signs say all around the state, we're in this together. So hang in there. What I'm going to talk about today is OSHA related, of course, health and safety. And the focus 4, what OSHA and NIOSH did some research. NIOSH is always doing research on health and safety, occupational health and safety issues. And we'll get into their stats. This was in the early 2000s, what brought this along. But they've determined that the vast majority of all injuries and fatalities, work-related, fall under 4 categories: electrical falls, struck bys, and caught in between. And again, I'll show you the stats. We'll go through this. Well, there we go. Sorry about that. So the focus 4, we got electrical. And as with OSHA, they'll show some of the most dangerous work in specific trades. So you can see how this worker is dressed. The PPE, you got a head care. This is like what the race car drivers wear. The heavy duty electrical gloves, the electrical hard hat and such, the shirts and the long pants. This person is dealing with extremely high voltage. It's not necessarily what you would have at a house, but it is extremely high voltage. Struck by hazards. I normally, in a normal training, I kind of blow through some of these because I try to keep it relevant, but we might be able to spend a little more time on some of this because part of the problem with these trainings, there's not a lot of feedback until the end, whereas how I like to do my trainings, I encourage feedback because I know not a lot of people started their very first job was with weatherization. So I ask, from your past, what was have you ever had any dealings or experience with OSHA or health and safety issues in general? So it's hard to do under this current format. So we may spend a little more time on some of this stuff, and it may look familiar to some of you. Some of you may have a background in it. So these guys are pouring and raking asphalt. And what they're really getting at here as far as struck by is the moving equipment. Caught in between a huge rooftop unit going in. And now caught in between and struck by can be, they can dovetail. And it will be the OSHA compliance officer at the job site who will determine which one it would be. So like if this thing, this piece of equipment, if wind caught it, for whatever reason it started moving side to side, that could technically be a struck by. If it lands on somebody, then now you've got perhaps a caught in between. And then fall hazards. This one and the electrical one is the ones I could usually make. Or not usually, I can always make very relevant to what our weatherization crews are doing, as well as the inspectors. So the fatality and injury data, again, this is from 03-04. This was the NIOSH and OSHA statistics. So as you can see, electrical was, and this is just fatality. Between 10%, struck by 24, and then falls greatly outnumbered everything else. All others over here, which is a large number, but that takes into account literally all others. Anybody who is killed or dies rather, sorry about that, guys. I don't know if my internet did something a little wonky there. Where am I at? All right. So, as I was saying, under the all others, 21%, anybody who dies while on the clock, most anybody, there are some loopholes. We've talked about that a couple weeks ago. But OSHA has to be notified within 8 hours, and it could be anything: a heart attack, traffic accident, if their job involves driving, and it could be something that's not their fault. If they're driving and somebody hits them or whatever, but OSHA still needs to be notified, and they will look into it. So that's what the all others. It's part of what the all others. So primary causes of electrocution fatalities: contact with overhead power lines. In our case, we're talking about the line that goes from the pole, the utility pole, off from the street or the alley, that goes to, hopefully there's a mast on the house, but sometimes these things are they're attached directly to the house and down to a meter. These things are, there's high voltage coming in, and they're easily touched in some cases. They're too easily accessible with ladders. My personal one, I've told some of you guys this story in class, that's a few years ago. Actually, it's been several years ago now, and one of my grandkids had my fishing rod out on the back deck, and he was swinging it around. And, I shot out on the deck and told him, no, don't do that there. Go over here, because he was far enough away that it wasn't a close thing, but it was still enough to get my attention. So, of course, my wife, the grandma bear, as I refer to her at times, that got her attention too. So the next day I was on the phone getting bids, calling electricians to come in, and it needed to be done. I mean, it was something, when I built the deck, it brought the service, and it's called a service drop. It goes from the pole to the house. When I built the deck 20 years ago or more, that brought the service drop too close. But my kids were older, and that wasn't a concern. But it suddenly did become a concern. So with what you guys do in the field, you're looking at ladders, bumping into them with your body while on a ladder. The other bullet points here: contact with live circuits. In panels, it says there, but also just in the walls. You drill into a sidewall, you could make contact. Knob and tube, or even if it's Romex going through the walls, you could hit one there. Poorly maintained cords and tools. A lot of our tools now are not corded; they're battery. But it still doesn't mean that the electric that you're running into isn't makes it any safer. But as far as our corded tools, we do need to maintain those. Look for nicks and abrasions, and we'll get into that. And then lightning strikes, which I don't hear much about in weatherization, but farmers and construction workers lead the way for lightning strikes every year, year in and year out. Struck by falling objects, like I mentioned a minute ago. You're getting into like rigging, things like that, things that we don't really run into much. Vehicle and equipment strikes, you got backing incidents, workers on foot. We have like some of the garages or warehouses that you guys work in, they're dark at times. As a driver of one of the box trucks is pulling in, backing in, going in forward, we have this issue at COAD too, that you're going, from a sunny, bright outside into a dark area. Even though there are overhead lights on, you really can't see what's going on. Some of our trucks are equipped with the warning, that beep, beep, beep. But that becomes like living next to train tracks or something. I saw Ryan Courier had mentioned something about that. He's lived next to train tracks, and you don't really notice it anymore. Same concept. You just grow kind of immune to it or something. So you gotta be on your toes. And again, all of these things here we'll talk a little more about. And then flying objects. You're getting into tools specifically, because this happened when I was in high school in our shop. One of our grinding wheels broke. I was nowhere near it, and unfortunately nobody was hurt or anything. But when that wheel came apart, it's like an explosion, and stuff went everywhere. But there are flying objects. Horseplay, that's not mentioned in there, but horseplay as far as flying objects go. Primary causes of caught in between fatalities. It's trenching, rotating equipment, again, unguarded parts. That's something that we may run into occasionally. And then again, with the equipment rollovers and maintenance. Fall-related fatalities, unprotected sides, edges, holes. You're getting into new construction with the holes, or major renovation where they're using future stairwells as ways of moving equipment and materials. So those holes, when they're not being used, they have to be guardrailed or some kind of protection. They can cover them. But for us, on a roof, you got unprotected sides and edges, residential roofing. Improperly constructed walking or working surfaces. Our houses vary as far as what you're walking on. The stairs, some of the basement stairs are iffy at best. And let's see, the improper use of access equipment, failure to properly use PFASs, that's personal fall arrest systems. And then slips and trips. Slips and trips are the most, I'm sorry, folks, I'm being distracted. My dog is out here barking at other dogs. I'm sorry. It's one of the pitfalls of doing training like this. But slips and trips is the leading cause of injuries in the workplace. So let's say single surface walking on like ice, parking lot, things like that. At the work site even, snow, wet ground, some of the plastic that if you're working lead safe, it can be a slip hazard. So citations due to these again, this goes back to 05, so these are old, these citations. But if you notice that a lot of these fall under fall, they're under the fall category. Ladders, that's a fall hazard, but ladders has their own subpart in the books. So it has its own citation issue. So as you see, back in 05, almost $1 million in citation. Let's see what leads the way here. Scaffolding, a little bit just over the fall protection scope and application. So training requirements, that's always a big one. As I've mentioned before in classes, and maybe in one of these type of sessions, that just because I hand you or my boss hands me a harness doesn't mean I've been trained. So I may have it on, I may be using it properly. But if there's no documentation showing where I have been trained, that could still be a citation. Electrical citations, the 1926, that's construction specifically. So wiring design, getting into, so this is the part of the stuff that I kind of gloss over during class. Struck by, you got head protection, overhead hazards, things that could fall, eye and face protection. That's something that's relevant to us, even though nobody, or I shouldn't say nobody, but few people take it seriously. But anytime you're using something that's throwing things, even if it's dust, or if you're laying in a way as you're working and you have dust or something falling into your face, you're supposed to protect your eyes and your face, but eyes at a minimum. And then caught in between citations, excavations, excavation protective systems. And we'll see woodworking equipment. That's some of what we use. And you'll see some examples, hand and power tools. And they'll have examples coming up. Falls, again, as we saw in the one citation, statistics or percentages, scaffolding leads the way. Fall protection scope, and then there's the training again. So 85% of all citations and 90% of dollars applied as fines are related to these four. They call them the focus four. And 79% of all fatalities are related to the focus four hazards. So again, NIOSH, this was part of their big push. It's been 17 years ago. So getting into electrical specifically, there are some pictures that some may find disturbing, so I apologize in advance because you'll go from a picture like this to something kind of gnarly looking, so that's your official heads up. But part of and I've mentioned this a couple weeks ago. Part of electrical issues and trainings are lockout tagout. So duct tape on a breaker is not a legal form of lockout tagout. You have uncut. You don't have the face plate here, so technically this could be an issue with an OSHA compliance officer. This pumping truck here for concrete, if you can see here, the tires have been blown off from it. It's because the boom here, it goes, you can't see it, but the boom went up and got into some overhead power. And electricity will find the path of least resistance. It's like water or a teenager, as I like to say. It'll get to where it wants to go, the easiest path. Now, it is true that a good set of tires, the cats on bulldozers or other types of heavy equipment, they will aid in protecting the operator. That is if the operator is inside the vehicle. If they are standing alongside, and the weight from some of these vehicles causes the metal here to get close enough to the ground that it will blow right through literally the rubber, as you can see here, the tires, and ground itself. Temporary wiring, let's see, I'm not going to talk about that one. Ground fault circuit interrupters, hopefully you guys are all using these, and they look just like this. They're identical to the ones that you probably have in your bathrooms and kitchens. They're COAD, and they've been COAD for 30 years probably or more, especially for new builds. But even if somebody's renovating a kitchen or a bathroom, most places require these. So having them as an extension cord made sense. As it says in that second bullet point there, they will stop the power in 1/40th of a second. So it's literally faster than the electricity. So what happens is if you're not familiar with these as far as on a job site, but maybe in your house, if somebody's running a hairdryer or they've got a blender going and a toaster or whatever, there's something going on, maybe something's getting wet and you don't know it, especially outside, this thing will trip. And as it says there, so it'll cut the power to this and to the tool that may be in your hands. So and if that keeps happening, and I tell people, don't blame this thing. Don't go over and kick it and throw it like it's doing something wrong. This thing is saving you possibly at least an injury. So this thing is doing what it's supposed to be doing. What you need to do is find out what's causing this thing to trip. And it could be that on the other end, it could be several things. But don't blame that thing there. It's doing its job. Let's see, that's for electrical engineers. This is something that OSHA likes to see as part of their electrical safety program. And it doesn't matter what the trade is. So they want their electrical, they would like for a company's electrical equipment that's corded especially to be inspected along with the extension cords. And what they like to see are color coded. And it doesn't have to be, this is just a suggestion, as it says here, best practice every 3 months. So if you have some white tape or something, and you pick a December, maybe before everybody goes away for the Christmas long weekend, or the couple days, at least everybody's off at that time, that somebody can inspect the cords, and then they can put the appropriate color. And then again in spring, summer, and fall, those are again, best practices. Those are the things that OSHA likes to see. And it's just a way of keeping up. We haven't gotten into the fall protection yet, but There are some companies like AT&T that require ladders. I don't even know if AT&T is still in business. Maybe they sold out. I don't know. But when they were in business, if they're not now, they would have their crew guys that are out in the vans with the ladders on top. They would have to bring their ladders in quarterly just to have them looked at. Make sure, especially if they had dropped, fallen off the pole or whatever it is they were leaning it on. Reverse polarity. This is just where the hot and neutral is mixed. It happens a lot in residential, especially a do-it-yourselfer. Somebody, they have the old two-prong outlets, so they need to switch it out. And this was 30 some years ago when a lot of TVs and stuff were coming with the grounding plug on part on the plug. So some of these guys were changing them out and wasn't putting the hot wire, properly to the brass and such. So reverse polarity, just what I said, hot wire and neutral wires are reversed. Even though a switch is off, the circuit could still be hot. So have it here with, but they almost look like a fat ink pen because they have the little thing that you stick in your pocket. You turn it on. It is not, as we try to tell people, I know Jim in particular, during his heat tech classes, so this is not for troubleshooting. Just because there's power going through that wire doesn't mean it's the appropriate amount of power. What that tick tracer, it's called voltage detector. What it does is it's just telling you if there is power in that. So like this example here, this light, it would be nice before this guy started messing with the wiring there. If he could have just put that tick tracer on there and it would have gone off, he would have known that just turning off the switch on the wall was not enough. And it could be because of this reverse polarity. There could be a three-way switch. The switch on the other wall could be sending power through it. So those tick tracers are pretty good to have, especially your initial inspectors, crew members who are crawling around looking for health and safety issues. The extension cords, this pretty common here. Again, a lot of our stuff are battery operated. I think the big hole saws that we're using, because of, I'm looking out my front door across the street at my neighbor's 2-story house, hitting every bay and going above windows and this and that. I think a lot of crews are still using corded for that because they don't want to come down off the ladders just to change a battery and such. So, but taken care of. And this is low-hanging fruit for OSHA, because there it is. It's out on the ground right in front of them. They don't have to ask for it necessarily. They could just walk through the yard and just follow it, trace it, and to find something like that. Now, what they will do is if they come across something like that or on a power tool, they will tell you to put it away and tag it. Put it somewhere and put a tag on it so people will know not to use it again. They do not cut up power. They don't cut up cords. If they are, then they are wrong in doing so. But OSHA has made it clear over the years they don't do that. And it does make for low-hanging fruit for a second go-around. So if they come back out in a couple weeks and the contractor is still using that cord, well, no, that could be another citation. Here's a mess that most of us can relate to. If you've done this work, if you're in the field long enough, meaning a couple of days in some cases, you're going to run across this. Our friend and former trainer, Steve Delahaye, he always called these things electrician knots. You get into attics, crawl spaces, basements, and what this typically is like a homeowner special. Somebody who has just enough knowledge of electricity to know to twist this wire onto that wire. And in this case, they actually put wire nuts on them. In a lot of cases, that's not happening. So it's definitely a hazard, and a lot of our crews that do everything, like our local agency here, HAPCAP, they're a one-stop shop, or whatever you want to call it. They do it all in-house. So their crews, or somebody who's been trained, is going to put these things properly in a junction box with the lid, with the cover, the appropriate cover, not duct tape. And we run into a lot of junction boxes where somebody has taken the cover off in order to add to the load, and then they didn't put the cover back on. So even if something is in the box, it still has to have the cover. So our crews are doing that. Electrical panel boxes, as I like to ask the class when I first click on this slide, is I say, where do you think this cover is? There's supposed to be a cover that goes around this. And there are a few people in every class who know, they've either been in weatherization long enough, or they come out of other trades or other work, that they know that box or that cover is on the floor, typically right below the breaker panel. So it's not hard to find. It's usually right there. Sometimes the screws are gone, but that has to be covered. Arc flash prevention. This is another one I usually fly through, but we'll look at it. A bank of meters here. There was an explosion, and an arc, let me see, does it say back here, typically lasts then a second. And as it says in that second bullet point, it's not necessarily the electricity that hurts or kills the worker in the arc flash. It is the high heat. It's like getting hit by the sun. It is explosive in nature, and it can ignite or melt conventional work clothing. So again, this bank of meters, there was an explosion, as you can see. It was mostly through here, but you can, this is gone. This is completely gone. And I think the next one, yeah, so here's a close-up. So this stuff basically becomes shrapnel, that real thick, heavy, it's glass-like, but it's like a plastic, but it's real thick. That explodes. You have these metal lugs in here, and it's shrapnel. It's leaving at a high rate of speed. So here's the victim. This is the worker who was standing in front of it. And if you remember, I think one of the first pictures, one of the first slides, was a worker working with high voltage, and he had the suit like this on. He had the head thing on and the gloves. So here you'll see their safety glasses, the suit itself, and you'll see where he took the brunt of the energy was in this shoulder area. You see his gloves are pretty much destroyed. And again, his glasses, excuse me. So this is the victim. And if you notice his upper body through here, where the suit absorbed much of the energy, you'll see that he's okay. The problem is from the neck up, which is unfortunately a problem for a lot of people. But in this case, you'll see that what's not laid out here by OSHA, and these are OSHA videos, OSHA photos. So the OSHA compliance officer put this stuff out, took a picture of it, and the one thing that's not there is that protective hood. And you can see where he had his safety glasses on even. See, electrical RA, we're getting into things here. So the NFPA 70E This is the electrical code. I'm trying to think of what else it's called, but it's part of the, the code. So the boundaries, again, appropriate PPE, not just for arc flash related, but we need training and PPE for electrical safety. So what's the best way to work on energized electrical equipment? You don't. You need to shut it down, lock it out. If it is a light switch, a breaker that best practice is that you're going to do a lockout, tag out. We have that stuff at COAD, and maybe in a future presentation, one of us will show you what those look like. But you can get a lock that goes on a light switch. The plate comes off, and the lock goes into the screws. And like with any lock, when the hasp part comes down, it covers the screws, and then the lock goes in. There's similar ones for breakers and fuses, things like that. Because if you're in somebody's house, and if you're not really communicating with the homeowner, if you're getting into some electrical up in the attic and you got light switches off in the base or on the first floor or whatever, they may not know what it is you're doing up there. So they go over and click on that switch. It could light you up. Overhead power lines, again, for us, we're thinking more in lines of the line that goes from the pole to the house, which again is called the service drop. Here's another asphalt truck, a lot of weight on these things, and it got into some overhead power lines, and this is the remnants of where it was sitting. The tires exploded. It's like that one picture you've seen. Here, a dump truck, same thing. The tires were blown off the wheels. You can see some damage to the new asphalt. There's a piece here. How far did the rubber fly? How far did parts maybe of the metal, how far did it go? I don't know. But again, these are OSHA photos. Here's a victim in the cherry picker, got into its overhead power again. And this is the unfortunate, as it says there, the sad reality. Sometimes it's not the victim's fault. Sometimes it is. The little town I live in northern Athens County, several years ago, there was the town I live in has their own electric and water. So they have their own workers. It's not AEP or whoever. And a guy who was retired came back to fill in for somebody who was on vacation, and he was killed doing something similar. He's working in a bucket on overhead power. And it's, people who, and you'll hear this theme throughout my trainings, especially the safety ones, is that we lose respect, or in some cases, people never have respect for the hazard. Oh yeah, I work on things hot. You just got to be a little more, no. And fall protection, people stand on that tray of a step ladder or just various things. They have that mindset that, I've done this a million times, and all it takes is that 1,000,001 time. So power line facts, overhead lines are typically not insulated, which is true. People see like that rubber or that plastic looking thing that goes across. That is there to protect, as it says there, for weather. That's it. How do birds sit on the wire? I think it's somewhat common knowledge now. It's they sit there. It's not because they're special animals and they're immune to electricity. They're not grounded. They're just sitting there. So if that thing was low enough to where they could step off that wire and have 1 foot on the ground and there would be an explosion of feathers. Over 90% of the contacts occur on overhead distribution lines. Operators are normally safe if they stay on the equipment. Again, it's the ground personnel are over 8 times more likely to be killed. So the operator, here's a graphic photo. I won't hang long on here, but as you can see in that photo, that it's when it leaves the body, especially high voltage, it leaves very violently. Again, he may have been leaning up against a piece of equipment. He completed the ground is what it comes down to. Electricity is very scientific, but it's very simple. It tries to find a path to ground. Lightning, and that's what we do. So, like equipment, as I was saying, the operators, if they stay on the vehicle, so if one of our box trucks, if the driver inadvertently, they go through a backyard or something, they're trying to get into a certain area, and they get into the overhead, the service drop coming from the pole, they should be okay sitting in the truck. It's the ground folks, so it's their coworker who is outside, who needs to be warned. Don't try to touch the truck, because again, they will complete the ground. So all equipment, ladder, scaffold, cranes, trucks, forklifts must maintain a minimum of 10 feet. Now it does change, as it says here, you add 0.4 inches for every blah, blah, blah. But for us, primarily working on ladders around the mast, the service drop and the mast as such, a minimum of 10 feet. How are you going to work around, areas where you got to get a ladder in there closer? That could be
And he froze.
thing here. It provides, if you will, a method to put materials up here so they're not using ladders. So safe distance. People working in tree trimmers and so forth. Okay, yeah, here's an example. Somebody got into dissipate. As farther out from the vehicle it goes, it does dissipate. When I taught an OSHA 30 class for a few years at our local technical college, the students, it was for heavy equipment. The students there told me when we got to this slide that was something that they actually worked on in class, was how to exit a vehicle if it got into electric, because sometimes it's not safe to be on the vehicle. So, but as you know, if contact occurs, stay on the machine if possible, warn others to stay away, notify the power company. And you can attempt to move away, but assure line is not connected. So this was one of the exercises the students were telling me that they would do over there. You jump from the machine. Again, don't step off the machine where you're touching it or you're in any way, and you're touching the ground. So incident-free planning, or I'm sorry, how to stay incident-free. We plan, train, inspect, oversight, lessons learned, and then reevaluate. And for us, as for most construction, a lot of the construction, they're there for months sometimes, building things, so they get familiar with the area. For our crews, if they're hitting it, they're in a couple houses a week, if not more, especially the inspectors. The inspectors are in a couple a day. So it's not as easy to plan, every day, but there are some things that you can. Again, I really stress for the inspectors when you're pointing out hazards. In this case, it's electrical. but make sure, you know, that it's on that work order, you know, whatever the hazard is. The immediately dangerous to life and health stuff as well, not just electrical. Struck by hazards. I'll tell you what, I know we've been giving breaks, and this is a pretty natural, we've been going about 45 minutes, so we'll take about a 15-minute here. So at 11 o'clock, we'll get started back with the struck by, and we'll kind of fly through these, and we'll get to the fall hazard information, something that's more relevant. So I'll see you in 15.
All right, Caleb, I need you to lay down, buddy.
Hold on.
Hi, Wyatt.
Hello.
Well, it's awful quiet out there today. I hit mute and got me some tea, but I could still listen in, and hope I haven't put everybody to sleep already. I know it's a Monday morning. It's beautiful where I'm at. Sun shining.
I'm still here, Kevin.
All right, thanks, Dave.
I can't see outside though, but the walls look marvelous in here. Yeah, Sam's got everything clean inside here.
Yeah, people were probably afraid to unmute
Yeah.
Well played.
if they were tuned in on Friday and they heard how bad it could get there. And I'm cool with that. That's fine.
Are you coming in here today?
Yeah.
Cool, because I got some PowerPoint questions. Cole and I has been going over tomorrow's session, and I'm gonna try it myself when we get done here. But I got a few questions for you when you come in about PowerPoint.
Will do.
Cool.
Tell you, when Rudy's in, if I'm not there and Rudy's in, he's a good one to ask.
Is he coming in today as well?
I don't think so.
Oh, okay.
I haven't heard. I haven't seen Jim on either. I don't know.
Yeah, I haven't heard anything from Jim today. He might be reviewing them videos that I dropped off there Friday. He said he was going to take the weekend off, and I don't blame him.
Oh, I did.
Yeah, me too, man. When I got back from Jim's, I closed the laptop after submitting my time for the second time, and then I had to submit my time again today for the third time. So we'll see how that works out.
Why again today?
I forgot to code one day out of last week on my work log from home. Even though I was in here, I forgot to put the code down on it. So
Who caught that?
it was from Bobby,
Oh, okay.
the email that I received today.
I also saw where I think it was you that put on one of the days last year's weatherization code.
Oh, I may have, yeah. Yeah.
You started off like the first couple of hours under the 19, but then it went to 18.
Yeah. Blonde hair, man. Blonde hair.
Where it's growing so long, it's distracting.
Yeah. Yeah.
It's going to be in your eyes before you know it on a windy day.
I know.
Yeah, Dave, Rudy's going to be in tomorrow there and stuff. He's got another webinar to do, so he's going to be in tomorrow.
Okay. Tomorrow will be too late.
Well, I understand, but he's not coming in today, so.
I'll try to get it figured out today.
I'll be in this afternoon.
I don't imagine it's too hard.
All right, we'll go ahead and get started back. Like I said, the struck by hazards, I'm going to, in typical fashion, even when I'm doing this under normal circumstances, I kind of blow through it because a lot of it doesn't pertain to what we do. Boom strikes. So fatalities, handling loads, rigging, improper rigging. Let's see. And during class, I usually ask, what are some of the hazards that, even if you're very unfamiliar with OSHA regulations, sometimes we know a hazard when we see it. It's common sense. So like, here's one, this guy here, of course, one of the first things that's pointed out is that he has no fall protection, which is true. He's handling this material here. It's some kind of a beam, some kind of structural item. And when the crane's bringing it down, and sometimes we don't notice, but there's a guy over here on this side and probably up here who's handling the other side of this. If one of them loses their balance just slightly and pushes that thing one way or the other, it could knock him off balance. And the sad irony, if this guy was to have gotten hurt, again, this is an OSHA photograph. Here is the lift that he was there to take him on up to where he needs to be. Or maybe that's as high as it'll go, whatever the cause or whatever it is. But you can see that he climbed out of his, what was providing him with his fall protection. This is what OSHA would call a near miss. You can see on the seat, there's some kind of fins from something that shot in through the glass. A lot of this heavy equipment, because they're looking up, there's glass above them. I'm assuming this thing didn't have anybody in it. The operator was gone, because these things are so tight when you sit in on these cockpits that there's really no room to roll out of the way, had the operator seen this coming. And there's no red stains or chunks of things there, so it tells me that this would go down as a near miss. The operator fortunately wasn't in there. Let's see. So highway worker fatalities. We hear about these periodically. They've gotten a lot safer. Literally the contractors that work on the highways, due to the state DOT rules along with OSHA's. So workers on foot, 57% of fatalities on highways. And it says highways, but it's also streets. So as I tell our crews during class, if you're working on a busy street and you're jumping in and out of the back of a truck, you're doing different things. People on their phones, not paying attention. They're blown by school buses and stuff too, so they're not going to pay you any mind. So just be aware of that. I've seen that some of the crews or some of the agencies are providing like the reflective shirts that has their logo on the back. That's pretty cool. Here's, who won? The cat truck won. This is, what in weatherization, we're familiar with a CAZ, combustion appliance zone, but OSHA calls this a CAZ also. This is a controlled access zone. So this red truck is not supposed to be in here. This truck here has very limited vision, as you can see. So on my notes, this PowerPoint provides notes and it tells you what all happened and such. The driver was not in this truck either, fortunately. But he got out, left it sit there for whatever reason, and the other driver didn't see him, didn't see the truck. And that could have just easily been horrible. So this, get on the highway, but this is similar, I guess, to jumping in and out of trucks or whatever along streets. This guy here has a silhouette that, he's going to be seen all right, but if you're skinny enough, this guy here, he stepped out. So if OSHA, and you can see there's a car here, so there is traffic. So what OSHA would tell these guys here, if you're going to take a break, you're waiting your turn in line with the asphalt, do it over here. They should have reflective, at least a reflective vest. Here's another case of that, like the electrical part I was telling you. Somebody says, I've done this a million times, or they're in such a hurry they're not paying attention. The driver of the dump truck could have their foot on the clutch. It could, it just get pinched in the worst way. Same here, same concept. I've done this a million times. Now these trucks, they have a locking safety mechanism that would go to the bed up here and to the frame, and it's a shoring thing. It shores it up, and then there's a locking device so that if the hydraulics was to give, this guy here would get hurt. Let's see. Equipment, rollovers and such, this stuff does vibrate while it's sitting there running. Wear your seatbelt. I remember during the days of ARA, we'd pull in, like me and Jamie or whoever, we'd pull into an agency and to do a training, and these guys would be leaving, and they're in trucks that have bucket seats, and there was 3 guys in the truck. So it's like somebody, that drywall bucket or whatever it is they're sitting on is not DOT approved. So make sure that, like in that case, it's a bench seat, whatever, that there's 3 seat belts available that are appropriate seat belts. Backing equipment, I've already kind of mentioned this. Some of you guys work in, if you're coming out of a bright, like a sunny day, like it's looking like it's going to be where I'm at, and you go in and you're pulling into a garage, even though it may be well lit, it's still, it's like being snowblind or something. It's spotty at best. So having a spotter in some of those areas, and you don't need to be the smartest guy. You don't have to be the one who can split atoms to know, you stop and you can go, so you need somebody controlling the area. High visibility clothing. Again, in certain areas, you guys at work, even again where I'm at, it's a rural area. I would say the community action weatherization program would be seen as being a rural program, but we have towns that they work into. So working on the streets, those things are nice. We don't need that. This is one where I normally stop and say, what's wrong with this picture? Well, it's this jack. This is hydraulics. This is not, it's made to lift the equipment up, and then there's supposed to be jack stands. They call different things, but they would go in here to hold the equipment up. The problem with this is these things can leak. I worked for a carpenter years ago, and we jacked up the side of a house, and one of his bottle jacks leaked. So we'd have to keep going back and looking back about how stupid that was. But in this guy's case especially, down here it's kind of the same thing. He's using hydraulics. He's using the hoe part here to raise this equipment up so he can work on the tracks here. And I've actually seen this. I was driving by. I didn't know the guy. He was out in the field, but he was doing something to his equipment, and he had to jack it up. And he was using that. That is not appropriate. No, we don't need that. Nail guns. If you guys are using finish nailers, the pass loads and such, just be aware, that you could have issues. This is one, the x-rays. This guy had a real bad day, a nail through the eye, through the teeth. I don't know. It's not the same guy, but a different victim over here. So these things, especially when there's horseplay or just carelessness in general, you're shooting through material that's not really made for that. Powder actuated tools, I doubt if we're using these, certainly for weatherization. OSHA looks at these things like they're loaded weapons or a loaded handgun because they come in um, 22s and 38s and such. But again, I doubt very much we're using something like that for weatherization. So how to be incident-free, planning, training, inspection, oversight, lessons learned, and then to reevaluate. So caught in between hazards. So here's another one that I like to take a little time on in class. Because I just ask, what does common sense tell you the hazard? We haven't mentioned yet, I don't think, this is caught in between, but falls. That's usually one of the verbal quizzes I give. Does anybody know how high off the floor or the ground you have to be before you have to use some sort of fall protection? And there's various types of fall protection. And the answer is 6 feet in construction, 5 feet general industry. So in this setting here, anybody working over 6 feet off the ground is supposed to have some sort of fall protection. And a lot of people lean this way, what about this guy here? Well, I doubt he's 6 feet off the ground. He's standing on rebar. Looks like they're getting ready to pour concrete. And you can see where he's standing on something. So this would require another form of fall protection, because the problem is falling on the same surface, because this could be an impaling issue. You fall on that rebar. So there should be plywood or something placed there for him if he was to slip. The ladder, the homemade ladder, that is appropriate. Believe it or not, you can make a homemade ladder, but it has to be done out of specific material. And it is in the OSHA standards, what kind of real dense. It's like the scaffolding lumber. It'll say OSHA approved and such. But yeah, you can do homemade ladders. Here's a trench box. It looks like it's the right size. The problem is this thing here being lowered down. There's a guy down here who's standing, I don't know if he's trying to stand off to the side or not, but he's under this thing coming down. So that's not good. The ladder itself, and I'm going to point out some ladder, either, believe it or not, and they have some kind of a stake here or whatever to keep it from flipping when they get too far out here. But I'm sure they're just stepping off when they get out. So not a good situation at all. Soil mechanics, we're not going to talk about this. This was, I got a pretty good lesson actually in that heavy equipment class about how they take the soil, the person who's qualified to do it, and they will pour some water in it, and they basically kind of make like mud pies, and it depends on what type of soil it is. And they just pack it together and just see how it works, and then they have this little scale that they do. So that's way beyond what we do, but it's just kind of neat. Because it seems rather primitive, but it's very efficient. So basics here, I haven't mentioned this yet, but every hazard prevention has to have a competent person. And that's usually where the giggles start in class, because there's competent and then there's competent, I know. But what OSHA says a competent person is somebody who recognizes a hazard. So let's go back a couple slides. They recognize a hazard, and they have to have the authority to stop work to correct the hazard. So if any one of these guys who is standing outside of this trench box, if they are the competent person, then they should be stopping work and get that guy out of the way so that they can lower this thing in there. If somebody on this says, hey, this is dangerous, stop work, and they don't have the authority, then OSHA, even though they see it, they recognize it with common sense, OSHA training, confined space, and we'll get into that as far as rescue plans. Fall hazards, there's some rescue plan issues. So here's a trench box again. I'm not going to talk much about it. You've probably seen these alongside of the road. They're either getting ready to use them or they're finished and they just set them up there waiting on somebody to come get them. So the problem with these trench boxes is they're too low. Soil can collapse, into the whole point of these things is to keep a cave-in from happening. So, and then in this case, you've got this machinery up here that's possibly running and it's vibrating. So that's not a good thing from around here. The stuff could vibrate loose. Barricade excavations. And again, this is all that's really needed. It's kind of like for our lead stuff. All you got to do is have something up to indicate to anybody that this is not the place for you. You can't be in here. And again, this is called a CAS, a controlled access. Utility strikes, gas, water, electric. So a rescue plan, it's similar. This could be a confined space issue that these guys are practicing for. It's trenching. But some of the trenches are, and it doesn't really, when you get to over 4 feet, 5 feet deep, the bottom of those trenches could have oxygen deprivation. There could be things down there, CO buildup if there's a generator around. That could be bad news. So these are confined space issues, and we'll talk about what is confined, what's considered confined space. So what these guys are doing is they're practicing. So if we have a confined space program, then we have to show documentation that these guys are receiving training and then recertification training. And see, even though they're going down into a trench, they have fall protection on. And these harnesses are also cabled. You see this guy here, and the end of this cable up here is connected to some kind of a pulley system. So if he gets injured or he goes down, he can't get himself up that ladder, the person up top here, the attendant, will then turn on that pulley system and drag him out of there. So there's a lot to it, and when and I was telling you a couple weeks ago when DOE wanted us, or weatherization in general, to start, enforcing, for lack of a better word, the confined space in construction was what I was used to. And it's like, man alive, this is going to be too much. But it ended up not being what I was afraid it was. Let's see, things collapsing, crushing, fatalities. Again, here's that tape area. That's the controlled access zone, keeping people out. Sorry about that. That's one of the shock and awe pictures. That's if something gets a hold of you, you're caught. Rings, shirts, long sleeve shirts. There's some tasks that require you to keep your sleeves rolled down and buttoned with gloves. And then there's other tasks that require you to roll, if you have long sleeves, to roll them up so that they don't get caught in moving equipment. So as with electric, which is what we're probably most accustomed to when it comes to lockout, tag out, any piece of equipment that runs on energy. So it could be gravity, hydraulics, whatever. If it's being worked on, if the worker is getting in there somewhere, then it has to be locked out and then tagged. Just like it's just like the electrical. There's a lock, and then there's the name of the person who has the lock. Excuse me. So unguarded belts. To be honest with you, I've never tried to run our Crendel without the guards on it, so I'm not sure if it's possible. There's some machines that are set up that way that without the protection devices on them, they won't function. But I do know we have belts in the Crendel machine. The table saw up here. as you know, I've told people I got 2 of these left. One of them is a shop version and the other one is portable. And neither one of them have the cover that goes over this blade. So I'm as guilty as anybody. But there's supposed to be a guard over this. About 10 or plus years ago, some guy invented this thing. It's a sensor that goes on, that goes through here, and it will pick up, and they demonstrate it with a hot dog. So if you go to YouTube and you'll see that thing, it will stop this blade so fast. It's kind of like a GFCI with electricity, that it'll actually destroy the blade. But it happens so fast, you can't see it. So the guy who invented it was so cocky and confident that he was willing to use his own hand. And as you may imagine, a lot of places, the home and garden shows that he was setting this thing up, the trade shows, they wouldn't let him do that. So he was using a hot dog. And man, that thing, I said, I just encourage, just because it's a neat thing to see. It's a one, or it used to be, I don't know if he's made improvements to it, but it was a one incident piece of equipment. So once it did what it did, kind of like fall protection, once it activated, then it had to be replaced. It couldn't be used more than once. And hopefully you never have to use it the one. So the blade itself would kind of explode. Of us have at home. You may have it there at your shops. You see the guard on here. So as the saw is coming down into the material, it's the same concept. They're cutting metal 2x4s. They have a wheel here, but this guy he used a bolt to hold this thing up. So this thing's not functioning like it should, like this one is. So, you know, that should just be taken out of service. Can it be fixed? Maybe, but it should be taken out of service. Here's another quiz that I give in class, is like, which one of these guys is doing it the most right? Because there's errors in both, but which one is most correct? I'll give you a sip here to think about it. If you said it is Larry the Cable Guy up here, you're wrong. It's actually this guy down here. He's most correct. Sparks are flying. He has gloves on. He does not. His pants are tucked into his boots. His are not. OSHA likes to see that, because in this kind of world, sometimes we get flammable materials, liquids and stuff splashed on their legs. So they like to see the pants tucked in. They both have the safety glasses. I don't know if those are safety glasses, but yeah, he's got the shirtless or the sleeveless shirt on. So what they're using, the tool doesn't matter. It's the same concept. Whether he's using it to cut through, looks like rebar, and he's cutting through that metal. Let's see, dumping trucks, not really. So this is probably starting to look familiar. How do you remain incident free? You plan ahead, proper training. And again, there are some things that training, most of the training that like our crews would require can be done by a supervisor. A lot of the trainings can be done on the job site. Some of them are very specialized training. So if a supervisor does it, then they have to receive training to become a trainer. And that happens in a lot of the bigger construction jobs. And we'll talk a little more about that. So there's inspections, oversight, lessons learned, and again, reevaluation. So fall hazard. So this is probably a little more into our wheelhouse, even though the first picture is a flat commercial roof, it appears to be. But the fall protection requirements are the same whether it's commercial, or virtually the same, whether it's commercial or residential. So roofs, in the perfect world, a flat roof like this, they do have a guardrail system. There are guardrail systems out there for pitched roofs for like residential. You don't see them often. I don't know how expensive they are, but you don't see them that often. There's cheaper and easier forms of fall protection, I guess. This, again, here's another controlled access zone. It's not in here, but it's between this parapet and this flagged system here. So the only, this is another little quiz that I give in class. It's like, which guys are doing it right and which guys are doing it wrong. And usually we look at we have 4 guys here without the hard hats. We got the 2 that have the hard hats. When do we need head protection? Well, when there's an overhead hazard. So in this case, there's really not an overhead hazard that I can see. So the 4 guys who are not wearing hard hats aren't necessarily doing it wrong or in violation. The guys that are wearing hard hats, it's probably a work mandate. There are a lot of employers out there who say that, when you're on the job site, it doesn't matter. Even if you're in your truck, you're going to wear head protection, and they can do that. The rules that we talk about in class, and I guess a few of them that we may discuss here, as with any code, excuse me, or any law, it is the bare minimum. This is what OSHA requires at a minimum. So an employer can always go one step up. And I always use the example of the people who are mowing alongside the highways, or the men and women who are working on the highway crews themselves, the flaggers. They're all wearing hard hats. Well, that's a state of Ohio requirement. Even if it's not a state employee, many municipalities use it also, the city of Columbus, I'm sure. So if a contractor, let's say a paving contractor, is working for the state, that's part of the deal. When they bid on a job, they're agreeing that all of their workers are going to have hard hats. Fall protection, this residential, and I have a video that I'll show you later, not today, and it's real brief. It's like 6 minutes. Excuse me, but it's how to attach this to the roof. And the best practice is not the way this guy did it. The best practice is to remove the ridge shingles so that this is sitting almost on structure, almost completely on the plywood or the OSB. There are probably a dozen holes on each side that you run nails, 16 penny nails, and it has to go into, again, structure. When I say structure, OSHA means the engineering portion of the roof. So like the rafters, the joists, whatever. It can't just go into the plywood. That's not cool. This one gives this guy I ran in there so he can move up and down the roof without having to unhook and hook back up. That would be down here to this rope. This is becoming a lost trade, I think. Slate, guys working on slate. But what they have set up here is staging for their material. You can see it there. This is not for fall protection. They have their fall protection on. Excuse me. The guys down here, they're behind this gate here that opens so they can get material on and off. They're behind fall. This is fall protection here, the guardrail system. So they don't have to have the harnesses on. These guys do. Now, up until 2010, I think, residential roofers had a variance they could use, they called them slide guards. They could use 2x4s that they could nail into, like on an asphalt roof. They could attach to the roof, and they didn't have to wear the harnesses, for example. That was considered fall protection. The problem is as they're tearing off roof or old roof, or they're just throwing scraps, that stuff would land on that 2x4. It only sticks up 1.5 inches. So what they were, in some cases, what they were constructing was a ramp. So somebody would lose their balance, start to slide, and that thing, it offered zero protection. They would slide right over top of it. So this fall protection is designed in a way with these harnesses that if he ever fell, he's not, if this stuff wasn't here, he's not going to fall all the way down and then off the side. This thing is designed, you can't go any farther than 6 feet, but you really want it to be designed that, you know, if he slips and falls, he's only going to slide, you know, a couple of feet. And that's where, again, the for a PFAS, a personal fall arrest system, that does require specialized training, and it's like a week-long training. So here's 3 of the more popular versions of fall protection, and this is another one of the in-class quizzes, verbal quizzes I give. And I ask, which one would you rather be a part of? If you were the person working out on the roof, what would you rather be a part of? Do you want a guardrail, warning lines, a safety monitor? And that is a coworker who, that is his or her only job is to watch this guy work. Now, I know there's a joke there, you know, every job has that person already. But in this case, this safety monitor up here cannot be doing anything else. Their entire purpose on that roof is to protect this guy. So he's already, just through this little sketching, he's already too close to the roof. He should be turned around and pushing that seaming piece of equipment towards the edge, not backing towards it. But they can't be on their phones. They can't be talking on their phones either. They can't, you know, so that's their only job. The problem with a safety monitor is sometimes on a roof, it can get loud. You got street traffic down here, the machine that he's using. Maybe there's heating and cooling equipment, things like that. So it can be a little loud. A lot of the students always pick this one, the fall arrest, the harness. Of these 3, 2 of them prevent the falls. They're designed to prevent the fall. The fall arrest stops the fall. So this thing is designed to only work if this guy falls. Again, these other 2 are to prevent the fall itself. So why do most roofers or people work on roofs that are using fall equipment, safety equipment, use this? The training is easy and the equipment is cheap. And again, you don't have to be a rocket surgeon to be able to use that. Now, the person who's designing it, the fall protection for that job site, they have to be trained as well. So fall restraints, okay, so they're using this, the warning line system along with the parapets. And technically the only people allowed to work between the warning lines and this wall, this parapet, are roofers. You can access this if this is the only way up there. A lot of these commercial buildings have a scuttle, so you don't have to come up over the edge. So there's no reason to be out there for your average worker. Only roofers are permitted to be out there. I've never quite understood this. We make fun of it in class, the guys defying gravity or something, I don't know. So here's an example of if there was a safety monitor on the roof trying to yell at this guy, because he is literally a half a step backwards from having a bad day. there's just no, and again, we just, he's focused. He's thinking about what he's going to do tonight. Get this over with. I got to do this, do this, do this. And he's worked at this job now for a couple of months, maybe. So there's a certain comfort level as well, I guess. What's wrong with this picture? Well, these guys all have their fall arrest. His looks a little loose. They all have their systems on. These are not fall arrest. These are to prevent the fall, even though they're wearing the harness. Because these come to like a pulley system. OSHA compares them to the safety device in your car for your seatbelt. So they can walk freely, and this thing will give slack. But the minute they run or they fall, they do something, it'll catch. Now, how's it? I mean, that stops the fall. This is set up, though, that these things will only go maybe 10 feet. So if you get to the leading edge here is 11 feet away, then that's going to prevent the fall because it'll only go so far. The problem with this picture is there's a big hole right here. And it doesn't look like that's where this sheet of OSB is going either. So they may be using this hole to pass up equipment. Maybe there's a ladder on the other side. That's how they're coming up and down. And they got trip hazards back here. They're caulking guns, the nail gun itself. And then these things can be trip hazards also. So that's an issue, major issue. So for holes like that, they do want them guardrailed or covers put on them. I'm going to kind of go past this. This stuff that this is a little more relevant, even though it's a commercial building with the metal studs. Most accidents, as it says there at the top, fall accidents, that is, are slips, trips, and falls, and from single surface. Due to, as it says, housekeeping. OSHA has a rule, and it's a housekeeping rule. And it doesn't, again, it has nothing to do with laundry or dishes in the sink housekeeping. This is keeping debris and trash off the floor. Because if you have a worker coming through here with stuff in their arms and they can't see the floor where they're walking, they can slip or trip on this stuff. This picture, it's well lit. It's already been a long morning. It's well lit through here. But again, in some cases, that's not the case. But if they're carrying something in front of them, they may not be able to see where they're going. Stairways, we won't talk much about them. I know some of the basements, you guys go up and down those stairs. Those stairs are not the greatest in some cases. So use your best judgment and be safe. Scaffolds and ladders, we're not going to talk much about that. When we did training with mobile homes in the field, we always took out scaffolding. It made it nice for the training itself because we could get several people up onto the scaffolding to take turns as we were lifting the roof and then sticking the 2x6 or 2x8 in there and blowing in insulation. And if you ever get a chance to work on a scaffold, you probably won't like going back to a ladder much, but I know scaffolding doesn't always have a place at our homes. The mobile home parks, most of them, even in our area where it's hilly, seems like they're in flat areas. So it was good to be able to use scaffolding. Scaffolding, there are a couple of urban legends, if you will, on scaffolding. It does not take forever to set up. 2 people can do it in minutes. You can move them. You could 2 people can pick up the scaffolding for what we do and move without disassembling it, but moving it down the house. The one thing that is true, they do take up valuable space on the trucks. So that is a major headache when we lose space. Let's see, these mud sills, they go under so the scaffolding doesn't sink. You can't climb up and down the cross bucks. That's not the way to go in and out. And for scaffolding, just this is more of a barroom trivia type information. A competent person, which I'm not sure is this guy, I always like this picture because, again, these are OSHA pictures. So he's looking back and he's realizing he just got caught. But a competent person on this job site has to determine if this scaffolding material here is appropriate for the weight of this brick, along with the weight of the workers that's going to be up there. And what you can't see is the mortar that they're using to attach these bricks to one another into the building. So there are some things that do take specialized training that you can't just watch an OSHA video to get. Let's see, accesses. Again, I'm not going to talk much about these. This is the middle scaffold. This is the kind that we have at COAD. And you can work 10 feet off the ground on scaffolding before you have to put up the guardrails. This is a Baker type scaffold. These come with wheels. Let's see, we're getting into, I got a thing for ladders here in just a second. So you can't, no, that's a step ladder. Even though it's a tall one, it's still a step ladder nonetheless. Don't lean it up against walls. If you've ever worked in construction or even if you've helped people set rafters or trusses, what kind of fall protection can this guy use? What would OSHA tell him? Because he can't tie off to anything, right? He can't put on a harness. Well, OSHA would probably tell him to get a taller step ladder. You can't be standing on that. So get a taller step ladder and you can do that work. Let's see, working above. And I think most people ask, so you guys are aware of this on your extension ladders, and most people in class say, yeah, they are. So the bases, they do, for firm bases, it says here, sitting on a patio, or even if it's solid enough dirt. And this is for not so solid. So these turn into spikes. You can stomp it into the ground. Let's see, bridges. No, we're not talking about bridges. So let's see. Well, there it is. All right. I have a video here. Let me pause it. Or actually, I'm already paused. Sorry about that. Here. And as you can see there, it's on ladder safety. So we'll finish up the day because my allergies.
Every day throughout the U.S., ladders are used. Unfortunately, many workers do not know how to safely use this tool. Being aware of the hazards of ladders can easily prevent an injury to you or a coworker. As you already know, ladders are used in a variety of different situations. Misuse of ladders or other careless actions can result in serious injuries from falls or electrical shock. Falls from a ladder can result in broken bones, electrocution, and even death. This video program is designed to provide information on the proper selection, use, and maintenance of ladders, resulting in safe work practices. This training program will discuss load ratings, types of ladders, selecting the proper ladder, safety rules for all ladders, safety rules for step ladders, safety rules for straight ladders, defective ladders, proper ladder storage, training. Ladders are rated using a system of numbers and letters. Each designation refers to a load capacity of the ladder. Type 1AA ladder refers to a commercial grade heavy-duty use ladder. It has a weight capacity of 375 pounds and is available as a step ladder only. Type 1A ladder refers to an industrial grade heavy-duty use ladder. It has a weight capacity of 300 pounds. Type 1 ladder refers to an industrial grade general use ladder. It has a weight capacity of 250 pounds. Type 2 ladder refers to a commercial grade light use ladder. It has a weight capacity of 225 pounds. Type 3 ladder, household light duty use. It has a weight capacity of 200 pounds. Type 3 ladders should not be used in construction or general industry settings. There are many types of ladders and devices used for working at various heights. Some of the different items used are portable ladders, fixed ladders, step stools, combination ladders, shelf ladders, and site-built ladders, which are usually temporary. While many of the safety rules and guidelines discussed would apply to these different types of only possible to get 2 ladder feet on solid level ground. Portable ladders are made from the following materials: wood, metal, and fiberglass. Occasionally, you may find a ladder with a combination of materials, such as metal rungs with fiberglass side rails. To meet OSHA loading and strength requirements, all ladders should meet or exceed American National Standards Institute, ANSI, standards. All Type 1, 1A, and 1-2A wood, aluminum, and fiberglass ladders meet or exceed ANSI standards and therefore meet OSHA standards for ladders used in the workplace. Other types may not meet OSHA's standards and should not be used in construction or general industry settings. Always consult your company's rules and guidelines. If you do not understand or have questions, ask your supervisor. Consult with manufacturer's guidelines on the possible and appropriate uses of the ladder. Guidelines are often printed on the side rails of the ladder. Before using any ladder, make sure it is of sufficient strength to complete your task. Never use a metal ladder on or around live electrical components. Always use a wood or fiberglass ladder when working around electricity. Check the warning label to ensure the ladder is suitable to work around electricity. Never use a ladder that is wet around electricity. Before using a ladder, inspect it for damage, loose components, and general condition. Look for loose rungs, nails, bolts, and screws, cracked, broken, or split, badly gouged or worn rails, rungs, or cleats. The pre-job inspection is important and should become part of your routine. When on a ladder, always maintain 3-point contact. 1 hand and 2 feet, or 2 hands and 1 foot, should always be firmly in contact with the ladder. Always keep your belt buckle between the ladder side rails. This keeps your center of gravity in a safe zone. Always wear non-skid shoes when climbing a ladder. Keep your shoes clean. Keep ladders free of oil, grease, and other slipping hazards. Clean the rungs prior to climbing a ladder. Use ladders as they were intended to be used. Never use a step ladder in place of an extension ladder. Never load a ladder beyond the maximum intended load or the manufacturer's rated capacity. Always use ladders on stable and level surfaces. Never try and increase a ladder's height by placing the ladder on boxes or pails, etc. Never use ladders on slippery surfaces unless secured to prevent accidental movement. Always secure ladders when used in areas such as doorways, passageways, driveways, or other areas where they could be displaced. Barricade the area to keep traffic or activity away from the ladder. Only have 1 person on the ladder at a time. Have a second person hold the ladder while the other climbs. This will prevent the ladder from swaying out from underneath the climber. Do not move, shift, or extend ladders while in use. Use extreme caution when working around energized electrical equipment. Make sure the ladder has non-conductive side rails. Always face ladder when moving up or down. Use both hands when going up or down the ladder. Do not carry objects or loads that could cause you to lose your balance and fall. Hoist objects after you have reached your destination height. Don't climb a ladder if the weather is not conducive to climbing, high winds, rain, or snow. Never use the top or top step as a step or seat. Do not use cross bracing on backside of ladder for climbing or any other purpose. Paint tray should only be used for paint trays or cans. A stepladder needs to be braced in place by a metal spreader or locking devices. Never climb on a stepladder if it is not braced and locked. Never use a stepladder as a straight ladder. After raising a ladder to desired height, lock the side in place. Side rails must extend at least 3 feet above upper landing surface. Tie off the ladder to prevent movement. For every 4 feet in height from the ground to where the ladder is touching the support at the top, the bottom of the ladder should be 1 foot away from the wall. This is known as the 4-to-1 rule. As an example, if the ladder is resting against a 16-foot wall, the base of the ladder should be at 4 feet out from the wall. Never stand on the top 3 rungs of the ladder. Never place the ladder against a movable object. Portable ladders with structural defects must immediately be marked defective or tagged with "do not use" or similar language and taken out of use until repaired. Defects that would render a ladder not to be used would be broken or missing rungs, cleats or steps, broken or split rails, corroded components, or other faulty or defective components. All ladder repairs must restore the ladder to a condition meeting its original design criteria before the ladder can be returned to use. Repair work should only be done by qualified persons or the original manufacturer. Any ladder that cannot be repaired must be destroyed and discarded. Generally, it is best to destroy and discard any defective ladders and replace them. a ladder correctly is important in maintaining the ladder's integrity and usability. Whenever possible, store ladders vertically. If they must be stored horizontally, support the ladder in several places to avoid the rails from sagging. Ladders stored on the ground could become a tripping hazard. Never store them where they create a hazard. Whenever possible, store ladders out of the weather. Always store ladders away from heat or any other hazardous conditions that could compromise the integrity of the ladder. Employees must be trained to recognize hazards related to ladders and instructed on how to minimize those hazards. Employees must be trained by a competent person. The training is to include nature of fall hazards and the correct procedures for erecting, maintaining, and disassembling the fall protection systems to be used, proper use, placement, and care in handling of all ladders, and the maximum intended load carrying capacities of ladders used. Retraining is required for each employee as necessary so that the employee maintains the understanding and knowledge acquired concerning ladder safety. Remember that a fall from a ladder can easily cause a broken bone, back injury, or death. Always choose the correct ladder for the job. Ask yourself, how much weight will it need to hold? Will it be near electrical lines? How tall does it need to be? Inspect the ladder before each use. Look for loose rungs or cleats, loose nails, bolts and screws, cracked, broken or split, badly gouged or worn rails, rungs, or cleats. Always use the three-point rule with your body between the side rails when climbing any ladder. And finally, always face the ladder when climbing up or down.
Patients are receiving $144 every month.
Sorry about that. My my internet's been sketchy at best today. So, good. Are there any questions? Anybody still out there?
Yeah,
we're still here.
Okay.
So if you got a ladder, say if it's raining outside, and you need to set up a ladder, or do you even set up the ladder? Because the rungs on the ladders get wet too. So do you just bypass it to go to another day?
No, you don't have to. They use, again, they're giving best practice, which is to avoid it if you can. But if you're in a situation that you can't avoid it, but they want you to be extra careful. And something I didn't mention, and one of you may have the question, so I'm going to cut you off here, is that ladders is its own form of fall protection. So you can work more than 6 feet off the ground on a ladder without like a harness or something. Okay. So technically, well, it's been a while. I'm thinking it's like 60 feet you can work on a ladder without fall protection. which is insane to me. But yeah, anyway, the kind, working on a ladder when you're drilling your sidewalls and such, that's your form of fall protection. And as I showed in the video, what they want is both feet on the rungs while you're working. Anybody else? Pam wants to know, how productive is it? Explain yourself, Pam. I'm not sure I understand.
He's talking about using scaffolding for sidewall work.
Oh, using scaffolding?
For sidewall work.
Oh, you're only going to go so high with them. So if you're 2 stories, you're going to end up breaking out the extension ladders anyway. I doubt if any agency has that much scaffolding to go up 2 stories. But if you're on a relatively flat ground, what I liked about it was sure footing. You got tools that's laying on. They're at your feet, but it's not really a trip hazard so much because you'll have guardrails around you. As far as productivity, I don't know if you get much more, if any, out of scaffolding than what you would out of a ladder. Let's see, would you have to use safety harnesses for that? Now, if you don't need to use fall protection on scaffolding until you get to 10 feet. And what's adequate fall protection at 10 feet is the guardrail system.
I have a question, Kevin.
Yes.
They said that you have to have 3 points on a ladder, like 2 feet, 1 hand.
Yeah.
You can't do that when you drill sidewalls.
No, it's when you're climbing. When you're climbing or coming down. When you're and when you're working, they want at least both feet. And they have a rule. It's an unofficial rule. They call it the belt buckle rule. If you're leaning out, even if if somehow you can keep both feet on the rung, but the center of gravity's out. I mean, I've done it. We've all done it. Where you don't want to come down to do that last hole, the ladder and all that. But OSHA calls it the belt buckle rule. They want literally your belt buckle to stay inside of the ladder. Yeah, the 3-point thing is only for ascending and descending.
Okay, then I wanted to mention Friday. That movie was excellent. I learned a lot off of that movie.
Oh, thank you. It's one that I've enjoyed. I've seen it a few times, as you may imagine. I really wanted to have a conversation afterwards, but we couldn't. I know some people, when they see it for the first time, they're almost radicalized. It's all the more reason to hate big business and government. But thank you. I know in class we mentioned Libby, Montana, because of the vermiculite insulation and the asbestos. But we kind of, and it's not, the classes we do aren't asbestos classes, so there's really no reason to dive into it. But I think it's nice to let people know that there was a lot more to it than what we, I guess, teach in class. Anybody else? Okay, if that's it, then it's lunchtime. Hopefully you guys